We're going to go over the quadratic formula and how to use it to solve for x-intercepts of a quadratic equation. So what we're going to start out doing is looking at the formulas to make sure they're in the proper form. Quadratic equations have to be in the form of ax squared plus bx plus c equals 0 in order to use the quadratic formula. If you look at number 1, it is in the proper format. Number 2 is not. So we have to solve by adding 10x's and 21 to make these two 0 pairs. So I'll add 10x and 21 to this side, which means I also have to add it to this side, making my formula x squared plus 10x plus 21. Now, because I already have this one solved, I'm going to go through the steps. The quadratic formula is negative b plus and minus the square root of b squared minus 4 times a times c, and all of that is divided by 2a. So in order to use the quadratic formula, I need to write down what a, b, and c are. I'm also going to write down what d is, which would be the discriminant. The discriminant is everything that's inside the square root. So I'll do this process first, and then I will add and subtract it from the opposite of b, and then divide by 2a. So in this particular formula, in this particular equation, I have x squared, which means a is just 1. I have 10x, so b is 10. And I have plus 21, so c is 21. Now I need to figure out my discriminant, which will be the square root of b squared. Now I always put b in parentheses because if this ends up being a negative, I need it to be a positive once I square it. So we're going to square all that b is, not just the number, but also the sign. This one's positive, so it'll end up being positive. That's minus 4 times a is 1, and c is 21. So I have the square root of 100 minus 84, which means the discriminant is the square root of 16, or 4. Now I'll use that in the other part of my formula, which is b plus and minus 4 divided by 2a. I'll do that over here. So my b is 10, so a negative b would be negative 10 plus 4 divided by 2 times 1. Then it'll also be negative 10 minus 4 divided by 2 times 1. In this case, negative 10 and 4 is 6 divided by 2, so x is 3. Also, negative 10 minus 4 is negative 14. Sorry, this should have been negative. Negative 10 minus 14 is a negative, minus 4 is a negative 14 divided by 2, so it's also negative 7. So my solutions are x equals negative 3 and negative 7. If I look at that, this equation in a graphing calculator, I'm just going to put it straight in as I see it here, not up here. It's going to be x squared plus 10x plus 21. When I graph it, I will see that it crosses at negative 3, 4, 5, 6, and negative 7. It shows me where this crosses the x-axis. And that's exactly what the quadratic equation did. If I were to factor this, it would factor to x plus 3, x plus 7. The negative 3 would make this 0, make this term 0, which would mean that my whole term would be 0. Negative 7 would make this term 0, which would also make the whole term 0. So whenever we're dealing with quadratic equations, they have 3 possibilities. Either has 2 terms, in the case of this where it dips down below the x and returns back to the same quadrant. It could be one solution where it would dip down just to the x and then turn back up, or it could dip up to the x and turn back down, or it could be no solution where this parabola would come down and not ever touch the x-axis. And you would see that work out like this. I would end up with 0. When I end up with a number, I have two solutions. When I end up with my discriminant being a 0, then I only have one solution, because if this were 0, negative 10 plus 0 and negative 10 minus 0 would be the same value. The only time we'd have no solution is when you worked out your discriminant. Your calculator would give you an error. It would look something like this. I'm just going to show you what it would look like as opposed to doing the whole process. Or I guess I could do it. Let's say that when I squared it, I ended up with 100. Let me do it all. I had 100 minus 4 times 2 times 25. Now, when I do that, I get an error for non-real answers. And the reason for that is that 4 times 25 would be end up being 200. 100 minus 200 is a negative number. The square root of a negative number is always an irrational, a non-real number, sorry, because you cannot take the square root of a negative number. So when you see this error, it means that there is no solution. Let's go through and look at a couple of the other ones just to set up and make sure that we understand how to do A, B, and C. For this one, I would have to solve for by getting 4 to the other side, so I'd have 5x squared minus x plus, minus 4. So my A would be 5, my B would be negative 1, and my C would be negative 4. On this one, I have something a little bit different. I would solve by moving 2x, subtracting it from each side. So my A would be 4, my B would be negative 2, and my C, in this case, because I don't have a constant, would be 0. And if I were to do it over here to this one, I would have x squared minus 25 equals 0. I would have to get rid of this by subtracting it. In this case, my A would be 1, because there is no coefficient of x squared. My B would be 0, because I don't have an x term, and my C would be negative 25. I would still run all of these through the discriminant. I would find the discriminant for all of these by using just the square root portion of the quadratic formula, and then I take that number and add and subtract it from negative b, and then divide it by 2 times a. So that's a quadratic formula. It's great for problems that won't factor, or problems that just look too difficult to factor. Sometimes using the quadratic formula is best.